Good evening, everyone. How are you? I'm fine. So today we'll be doing the trigonometry grade 11. Okay. So I hope you are already enjoying it because it's an interesting topic. Hey guys, there's no electricity here, but we are learning as long as you can see. So in this grade 11, we have two identities. So we have the first identity, which is tan. These are the identities, and identities. So tan theta is the same as sine theta over cos theta. Do you know why I'm saying this? Remember from your soccer toya, tan, it is opposite over adjacent. And then what is my opposite sign? It is the sine. And then what is my adjacent? It is cos. You must know this. So this tan, this identity, it was derived from the ratios of tan. Angiti tan theta is equals to opposite over adjacent. So this opposite is now sine, and then this adjacent it is now cos. I think in grade 10 you're doing this, but now in grade 11 there's an identity that means tan theta is the same as sine theta over cos theta. And then the last one for grade 11, which is simple. Sine squared theta plus cos squared theta is equals to 1. You see, so this is just the simplest. So for grade 11 you're going to do the two identities. Wherever you see tan theta, you must change it to sine theta over cos theta. And be careful, if it is something like sine squared theta over cos theta, you cannot change it to tan. They must be the same. If here it is squared, even here it must be squared. Then it's gonna be tan squared theta. You see, if it is maybe sine theta over cos 2 theta, don't change it. Don't change it. It is not an identity. So wherever you see tan theta is equals to sine, wherever you see tan theta, change it to sine theta over cos theta. Wherever you see 1, you can take it back to be what sine squared theta plus cos squared theta. Or wherever you see sine squared theta plus cos squared theta, no go to it is equals to 1. Remember, for tan, you are two. The numerator and the denominator must be the same. Okay, so now let's check some examples. Okay, so yeah, be careful there. So these are the identities that are gonna be doing for this year. So number 1, simplify. So let's just say we have sine x over cos x times tan x. Okay, so this is sine x. I cannot change it to anything, so it's gonna be sine x over cos x. I can't change it again. This is gonna be cos x. Okay, and then manje, you can check something there. There's tan x, so I can change it to sine x over cos x. Okay, so now I can see something there. I can see something. Do you see something? Now I have cos x is being multiplied to sine x over cos x, and they are being divided. So let me just do like this, maybe times here, so that you can see clearly. So since they are multiplying, I can do this. This one cancel with this one cancel with this one, and I'm left with 1. So be careful when you're canceling your things. You must have two things. You must make sure your variables or numbers or whatever, they are what? Dividing or multiplying each other. If you see them adding or subtracting each other, no, you cannot cancel. They are wrong. If you see something like sine x plus cos x over cos x over sine x, maybe over cos x, maybe, and then here maybe this what cos x again, don't say this one cancel this one cancel with this one. Since there is an addition sign there, it means you cannot cancel. You only cancel if you have the numbers dividing each other or multiplying each other. Okay, so now let's check the second one. Tan squared theta minus 1 over cos squared theta. Okay, so now let's continue. You know the drill. We must change this and it sine squared theta over cos squared theta. What you see? What you can see what I'm doing, and then minus what? Minus 1 over cos squared theta. So now do check something. I want you to check something. I have the common denominator, so I'm gonna do this. Since I have the common denominator, I'm gonna put it in 119, so it's going to be cos squared theta. And guys, when you're solving this type of question, whereby you have the denominator and the numerator, solve the numerator before everything, because you don't touch the denominator. Please leave the denominator until you solve everything. So on top of them, I'm going to be left with sin squared theta minus 1, and then manje I'm going to continue. I don't touch my denominator, cos squared theta. But remember, what did I say? I didn't tell you. Sin squared theta can be represented as what? 1 minus cos squared theta. So let me put it here. Sin squared theta can be represented as 1 minus cos squared theta. Because if it happens, I make this one the subject, is going to be what? This sign goes to the other side, it becomes 1 minus cos squared theta. If it happens, I want to make this one the subject, is going to be what? Minus sin squared theta. So yeah, sin squared theta is going to be what? Put it in brackets, or you cannot put it, don't put it in brackets because there is no number in front of it. So it's going to be 1 minus cos squared theta minus 1. And then manje, be careful, this -1 and that one, they are common, they are numbers, because the negative is the only one that is being divided, multiplied to this cos. So it is going to be 1 minus 1, which is 0, and then I'm going to be left with negative cos squared theta over cos squared theta. Now I'm dividing, I can now do what? Cancel, and then I'm left with negative 1. Okay, can you see this? So you have to be careful, guys. So check, sin squared theta plus cos squared theta is equals to 1, and then sin squared theta can be written as 1 minus cos squared theta, and then cos squared theta can be written as 1 minus sin squared theta. And then when you want to simplify, you only divide the numbers, or cancel the numbers if they are dividing or multiplying. If they are adding or subtracting, you don't do that. You are not allowed to do that. You see? So you are not allowed to do that. You only cancel the common numbers or the common what if they are only the same. Okay, so let's check the next one. So now let's do the last 2 examples. We are simplifying. Let's now prove. So they are saying prove that this and this is equal to that. So there's the left hand side and the right hand side. So now I'm gonna consider, you do this, consider LHS. So you can tell them I'm taking which side, cos 3x, because sometimes you can consider this side. So this side must take you back to this one. Since I'm taking this one must take me to that side. Cos cubed x, cos cubed x plus cos x plus sine squared x. This is easy, guys. I have cos, that is, hey, wait, that is being multiplied to sine squared x. So if it is being multiplied, I have to check what's common. What's common? It is cos. So I have to do this, cos x, I open my bracket, cos cubed x divided by cos x, I'm gonna be left with what? Cos squared x plus cos x over cos x, it's out. I'm not gonna include it because it is being multiplied to sine squared x. So I'm gonna be left with sine squared x, and then what is cos x times cos squared x plus sine squared x, sine squared x, it is what? It is 1. Remember the identity there, which is what? Cos x, which is equals to the RHS. We are done. You see? Proven. We are done with this one. If this one is being added to another one, and this one is being multiplied to the other one, you check what's common. But if it was added to the other one, we were supposed to use another way. Okay, let's check the next one. Cos x over 1 minus sine x. So but here you have to be careful. This is the LHS, this right hand side. I'm gonna consider LHS, but manje, cos over sine, I can't take it to tan. Hey, what must I do? And now they are saying 1 plus sine x, when I have 1 minus sine x. Hey, I don't worry, guys. So until you wrote cos x over 1 minus sine x, you have to apply what is called conjugency. Apply conjugency. So conjugency is a method whereby we take the denominator, we take this thing and multiply it by the denominator and change the sign. So since here it is 1 minus sine x, I'm gonna say 1 plus sine x over 1 plus sine x, just like that. And then now I have to consider factor out the lowest denominator, but in highest common denominator, and then I'll have to multiply everything by the denominator. So it's gonna be something like this. Check this. check this out, check this out. I want you to check this now. Check this. Are you checking? It's gonna be cos x plus sine x cos x, which is multiplied. Do you see it? 1 times cos x is cos x, and then one button cos x times sine x, it is sine x cos x, over, let's do this one. So it's gonna be 1 plus sine x minus sine x minus sine squared x. This is basically cross multiplying, but you are not, like, it is the same as cross multiplying, but you are not really cross multiplying. So it is the same as saying, wait. It is the same as saying this one times that one, this one times that one. Can you see it? Yeah, because it is something like 1 times 1, 1, plus sine x, which is sine x, and then negative sine x times 1, it is negative sine x, and then negative sine x times sine x, it is what? Minus sine squared x. And then we continue. Then manje, you have to be careful there. Remember, what did I say? I have 1 plus sine x minus sine x minus sine squared x, which I can simplify it to what? I have the plus and minus, so I can do the like terms, and I have sine x and everything. So what is sine x minus sine x? It is 0. So I'm gonna write my thing again. So it's gonna be cos x plus sine x cos x. Remember, they are being multiplied over 1 minus sine squared x. You see? So since they are being multiplied and added and subtracted, plus minus, they are like terms. So this one and this one and that one, they are like terms. So I can do my thing there and then take it out. And then manje, remember, this one is 1 minus sine squared x, which I can write it as what? Cos squared x. So already for my denominator, I'm sorted cos squared x. Let's check that one up there. I have cos x plus sine x times cos x. Remember this one? You must factor out what's common, which is what? Cos x. Open bracket. I'm gonna be left with what? 1, since it is not multiplied to anything. 1 plus what? Sine x. The reason why I didn't include 1 here, it is because this one is being multiplied to this one, so there's no need for me to do my thing. So it will be like cos x 1 plus sine x over cos x cos x. But remember, when they are saying proof that this one is cos to that one, you have to maintain your thing. You have to maintain your numerator, your denominator, I mean, because lana the denominator was cos x. So since it is cos squared x, I have to do it like this so that I can follow my proof. And then manje, I have what? 1 plus sine x, it is there, and then I have to get rid of what? The cos x. So it's gonna be this one and that one. Then I'm left with 1 plus sine x over cos x, which is cos to the right hand side. Proven. You see, we are done. So for this one, if your cos or sine is multiplied to cos and sine, if there's there's addition and then there's multiplication, you check what's common. And then manje, if you see something like this, you have to apply conjugates, whereby you take the denominator and multiply it with you multiply the whole thing by the denominator, but you change the sign, because here it was minus, then there it is plus, and then you continue. Since there's this dot for multiplication, it means what I have to check what's common. And since this is 1 minus sine squared x, it has to be taken to cos squared x, and then manje, and the proof is saying cos x, so I have to maintain it by changing this to cos x so that these ones can cancel, and then I'm done. Okay, so thank you guys, and then we'll do the quadrants soon, and then reduction formulas, and then we are done with trigonometry. Then that's when you'll be looking at your general solution, the graphs and stuff. But yeah, for now you are done. So thank you guys.